Assalamu alaikum. Myself, Mohammed Jamshed from Mechatronics Department, Air University, Islamabad. Today, I am going to tell you about the ins and outs of H-bridge. In today's video, we are going to discuss what is an H-bridge, why H-bridge is called H-bridge, or why it is known as H-bridge, and the components required to identify circuit, basic circuit diagram, and all of the other components that we attach to the H-bridge to make it more advanced. Starting from the H-bridge. An H-bridge is an electronic circuit that allows a voltage to be applied across a load in either direction. It consists of four switches, which can be transistors or MOSFETs arranged in a configuration that resembles the letter H. The H-bridge is commonly used in motor control application where it allows the motor to rotate clockwise or counterclockwise depending on the polarity of the voltage applied to it. Now let me explain you in simple terms. It is a kind of a circuit made made in this type of H form. Like the circuit's construction makes an H. I will show you the circuit later. In this way, an H is formed. This H do the works of changing the polarity of the voltage applied. Like if we connect any of the load, which could be probably it is the motor that we apply, that we put in as a load between the H bridge. It will change its direction according to our needs and our inputs that we give. The inputs, it can be controlled using switches, any of the other microcontroller, and different. There are many components to control that, but the basic internal circuit would be that of an H bridge. Moving further, now why H bridge is called H bridge? By as you can see from this, the letter H. The letter H has similarly the letter H, our circuit also resembles this letter H. Like here, both switches are placed here, one at this position, one at this end, this end, this end, and in this middle horizontal line, the load is placed at this position. So that's why this circuit is known as H bridge. Moving further, what are the basic components required to make an H bridge? To make an H bridge, first of all, there should be a voltage source that may turns on and off the switches or may supply the power to the circuit. Then we have to use transistors or MOSFETs as a switch to control the flow of the current or to control the polarity of the voltage. Uh, so, in conclusion, we need four transistors or MOSFETs and two switches which may provide, which may control the inputs, and there should be minimum uh, one voltage source to give the power or to bias these transistors and other switches. Here, a word is written that. In addition, you will need a power supply to provide the voltage to switches and a con- control circuit to switch the transistors on and off in the correct sequence. This sequence matters a lot. When we'll discuss the circuit later, I will show you that how this sequence matters or what is the meaning of this sequence. Moving further, let me tell you the basic circuit diagram of this H bridge. Now let me use a drawing pen. Now you can see here S1, S2, S3, and S4. These are four switches which are placed here, and in between on this horizontal line, there's a DC motor. You can see from here that this is forming an H like in this way. That's why this is called an H bridge. Now moving further, here a voltage source is applied at this position. It could be VCC or any of the name, but there could be a voltage DC voltage source, and here a ground is connected. These switches could be either the transistors or the MOSFETs. The direction of the current through the load can be controlled by switching the appropriate switches on and off. Like uh, we can move the current from coming from this towards this, and then this we will get the motion of or the movement of this motor in the one direction. And similarly, we can also make the current to flow from to follow this path, which will make the motor to rotate in this direction. In this way, we can control the rotation of the motor using this circuit. Oh, let me explain you this basic circuit diagram using approach simulations. Here, as you can see, the components I have here are there are four transistors, one, two, three, and four. Here I am having four transistors. There is one voltage source, and this is the ground applied here. And this is basically the main load of how we have to control the direction. It could either be clockwise or it could either be anti-clockwise. This resistor used here, this one and this one, these are the current controlling resistors, and these are the switches. Switches switches are used to just make a connection between two separated circuits in this way. Like if we close this switch and connect it in this way, it will form a short circuit. But if it is open in this way, this will be considered as open circuit and no current will flow through it. This is work of transistors. Now let me start from this voltage source and moving further to all of the components. I will explain the circuit in more detail, and then further we will just focus on the advancements. Here, the collector of these both of the transistors placed upward is directly connected to this voltage source. The base of these four of the transistors is connected to these switches. Two of the transistors base is connected to one switch, and the other two are connected to and the other's base is connected to the other switch. It is because just to make our flow in this way, either or in this way. Further, we can see that the both of the switches are taking the voltage, or they are connected with this voltage source from here and here. Now, when I turn my circuit on, now both of the switches are open. Now, if I turn my simulation on, nothing happens now because these both of the circuits or these both of the switches, this one and this one, are still open now. But then when we close this one, the upper switch, our motor starts its rotation. Now let us follow the path that why the motor starts rotating. As the switch is closed, the current will follow this loop, and here it has two ways to go. One is this, and the other one is this. Here it will turn this transistor on. It will turn this transistor what? On. It will make this transistor on, and the current flowing through this will come and following this path. It will also turn this transistor on. When these watt transistors are on, they will allow from here the voltage source applied here, this one connected here. The current will start flowing from this as it is in the on state. It will behave as a short circuit here. Now the current has two paths, so it could be moved towards the right and it can move downward. But in the downward position, the circuit is still open. As there is no current on the base, the switch is open. This transistor has no current on its base, similarly as this transistor. So they will behave as an open circuit. The current will follow this path, and as this transistor is on, the current will come from here, and then it will get grounded by turning this motor in one direction. But if we turn these both switches on at the same time, it will make a short circuit and cause an explosion. So be careful while working with this. Now, if I turn this upper switch off and this lower switch on, now the lower switch or the lower loop, all of this path is closed. Similarly, this transistor is in on state, and this it is following mm, it is following this path and going towards this this the transistor's base. It will make this transistor on. When these watt of the transistors are in on state, these watt will be in the off state because there is no current flowing through their bases. There is no current flowing through their bases, so they will be off. Now, following the path of the current, a current coming from here will divide into two paths. One will go towards this base, and the other one will go towards and some amount of the current will comes towards this base. This will behave as a short circuit, and this will also behave as a short circuit. The current coming from here will enter this transistor and passes through it. Here it has two ways. This transistor is off, so it will behave as an open circuit. The current will follow this path, and when it comes here, it could see a ground. As this transistor is on, it will follow this path and gets grounded by and the direction of this motor is opposite now. And this transistor is also behaving as an open circuit, so current will not follow this path. I hope that the basic working of edge bridge would be clear. If you have any queries, you may ask in comments. Now, let us make these simulations smoothly. If we turn this circuit on, the upper switch close, if we make this switch close, the motor is moving in anti-clockwise direction. And if I open the upper one and close the lower one, so the motor is following the clockwise direction. In this way, we can control the direction of a motor using an edge bridge. Now we can also make this circuit similarly. The basic circuit is only this one. We can further modify it to make ourselves convenient and to enhance the protection and different other factors. But the basic principle on which this circuit works is explained till now. Now, in this circuit, there are very much of large of the chances uh, of getting short and these kind of factors, that like safety factor is very much less in this basic circuit. To enhance this safety factor, we are using optocouplers we will use optocouplers in this circuit. Now the question is, what are optocouplers? As the name indicates, opto and couplers. Opto means light dependent, or anything connected with the light or vision is known is called as opto. And couplers mean the connection between two things. Like optocouplers are the optoelectronic devices. Optoelectronic devices means the light dependent or vision dependent or brightness dependent electronic devices that isolate two circuits from each other while allowing them to communicate. This seems to be weird that two circuits are not connected physically, but they are connected optically. How is this possible? Uh, Let me explain you with the little annotation. Its construction is of this type. Like here, an LED is connected, and at this side, I am very much larger. And on the other side, here a collector base emitter. This is known as a phototransistor, which depends on light. Like when this LED gets turns on, like when it gets voltage from here and ground from this side, this LED turns on. When light falls on the base of this transistor, it its collector and emitter will behave as a short circuit. Hope optocouplers would be clear. Now, what is the use of optocouplers in this circuit? They are commonly used in the H-bridge to provide electrical isolation between the control circuit and the higher voltage power circuit. This increases safety and reducing noise. If we see in the Proteus simulations, here the battery is directly connected with this switch and the and it is directly going through these transistors, so it will give us less stability and protection. Now, in this circuit, we have used optocoupler here. The device is connected uh, here and here are known as optocouplers. These are the connections made for their LEDs. Both of them have the similar connection, and here are its collector and emitter. Hope the construction of the optocoupler would be clear. And let me explain you one more thing that is known as flywheel diodes. Now you see these are the four diodes. You may think that what is the purpose of these diodes? Keep these diodes and their position in your mind. Flywheel diodes, also known as freewheeling diodes, are used in H-bridge circuit to protect the switches from voltage spikes that can occur when the load is switched off. They are connected in parallel with the switches and allow the current flowing through the load when the switches are turned off, preventing damage to the switches. Now let me explain you in simple words. Like when it is these diodes are mostly used with the relays because they have high inductance. Like when the load is turned off, a, a voltage is generated in the opposite direction or in the opposite polarity. Current will start to flow in the opposite direction, which may damage our devices. Like here, we are using the BJTs, bipolar junction transistors, which have base, collector, and emitter. They may get damaged if we do not use these flywheel diodes. How they prevent? They prevent in the way that when a voltage spike occurs or the voltage comes in the reverse direction, they uh, they allow the they allow the current to to follow their path or to flow through them instead of the device or any of the switch or any electrical component connected in parallel which we want to save. In this given circuit, you can see that the diodes are connected in parallel to all of these transistors just to avoid the voltage spikes or the back EMF generated when this motor get turns off. When this motor turns off, the current will come back in this direction, which may damage our electrical components. So flywheel diodes are used to make that the current may follow this path instead of following this path. Hope the idea of this flywheel diodes would be clear. Now let's run this circuit. The circuit would be split same like the opposite of the circuit switch is closed. Now let me explain you the working of optocouplers. You can see these both are separated, like there is no physical connection between them. But still, when we give the current here, this phototransistor turns on and allows the current to pass through this its emitter, and it will may further go through this transistor, and here this all of the circuit is same. Only the difference is these optocouplers and this switch that first the this LED turns on this one and this one, and then the phototransistor in front of them will also get turned on and allow and make this collector and emitter short. You can see that the collector of these both optocouplers are connected to this source directly from this node here, which is providing all of the power to them. And then if I open this switch, now this of the optocoupler, this upper one, this of the optocoupler is in the on state, like its LED is now on, and this phototransistor is now working. But when I turn this switch off and this switch on, similar happens from lower circuit. Now the LED of the upper optocoupler is off and its phototransistor is also off, from which I mean that there is no current flowing through it, and this is in the on state, which means that this its LED is on, its phototransistor is also on, and the current can flow through this, and the currents can flow through this. It is going through the base of this transistor and also this transistor. You can see that the in this way the circuit works. The other formation of this circuit at this side is same, just only the difference is that of these optocouplers and these diodes to increase the safety factor. Moving further, that if we are here in this given circuit, we are switching this manually. We are switching these switches manually by hand. But uh, can we also make them automatic, or they would be automated, like automated edge bridge? We can also call it automated edge bridge. For this purpose, we have to use a microcontroller name is Arduino. In the Arduino, we use high and low outputs to generate digital outputs like 1 and 0 to get 5 volts output or 0 volts output from its pins, and and there is a code written for it to get the desired output. So I have connected the Arduino here, and its source code is here. From the source code, I will try to explain you that what is happening in the code. Like I have declared two pins of the Arduino with their names, and then both of the pins are behaving as output. Now in the loop, I have said that one of the pin will get high, like one of these switches, the switches we're using there will get
closed. One of the switch will get closed. In this line, the switch is getting closed. And in the second line, there is a delay of 10 seconds. This delay is just this is the time at which the motor will remains on, and then I will make the same pin low. Again, the circuit will get open. Like the switch closed in the above line will get closed after it will get open after about 10 seconds, and then there will be a delay of 5 seconds. Like after 5 seconds, these are 5 seconds to make the motor come at rest and in steady position. Again, I will turn the other pin. This other pin is named as anti, like pin number 2. Pin number 2 will tap on, the high is written here. It will make the circuit close here. And when we close the circuit, the motor will start moving in the one direction, and and low means the circuit. And after 10 seconds, in the on state, the it will again become low. The circuit will again become open, and then there would be a delay of 5 seconds, and then again this will continue. It is behaving as a loop. Like this will again and again and again will be continuous, and it will not stop. Now, if we let us check this procedure by our simulations. Now, as you can see in this circuit, the one in the red is on now. I have closed both of the switches because now I am controlling this from this Arduino. Like you can see, after 10 seconds, it has turned blue. And after the delay of 5 seconds, the pin number 2, this pin number 2 has become on, and the this motor is moving in the other direction. And after the 10 seconds, the both of them became off. And after the delay of 5 seconds, this pin number 12 is again come high, like the loop has restarted itself, and the motor is moving in the opposite direction. Like by making these pins high and low, we are turning on and off these LEDs from on there. The whole of the other circuit is depending upon. Like all of these transistors, these 4 transistors will turn on and off from the current coming from this emitter of these both optocouplers. Now you can, if you focus on it, these pins are getting high and low simultaneously, like at different timings. If I zoom in, you could see that now both of these pins are off, like they are showing blue for 5 seconds, and after 5 seconds it has become on, and for 10 seconds it will remain on, and the motor will continue its motion in one direction. And when this turns blue, the motor gets stopped, and after the 5 seconds of stopping, motor will start moving in the other direction. In this way, we can control our H bridge using a microcontroller. Like we can shift the direction of the motor after a specific time by our will. This is the most advanced form of H bridge. Like the H bridge is connected with the microcontroller Arduino. Yeah, this Arduino works on the 1 and 0 principle. There are also inputs of analog inputs, but in this circuit we only need digital outputs. Like there should be only 2 states, on or off. Okay, and we also have We also have a video of our working circuit. Let me show you that.
अस्सलाम वालेकुम सर, इस सर्किट में हम
Like when we turn one of the switch, these are the biasing. Then here, when we turn one of the switch on, the motor will move in one direction. And when we turn the switch off, the motor will start moving in the opposite direction. In this way, an H bridge works. So moving back, today we have learned that an H bridge is an electronic circuit that allows a voltage to be applied across a load in either direction. And a widely used circuit in electronics. It consists of four switches arranged in an H shape. It can be controlled by a microcontroller such as Arduino, like we have did in our last task. Provide automatic switching off the motor direction. Optocouplers and Flyback diodes are commonly used in the H bridge and circuits to increase safety and reduces noise. Thank you so much all for watching the video. You may give your reviews and ask your questions in the comment section. Inshallah, I will try to answer those. Thank you so much. Allah Hafiz.